Alrighty, this is just a practice problem, a projectile motion problem where the object starts off at some height above the ground and is launched at some angle. I want to find out two things. Okay, so let's say this was a ball that someone kicked off of the roof of a very tall building. They kicked it off at a speed of 8 meters per second at an angle of 35 degrees to the horizontal. And I want to know, number one, how far from the building's base does it land? And number two, what is the speed of the ball when it lands? Now, please be careful. A lot of people want to say, well, it landed, now the speed is 0. That's not what I'm talking about. I'm talking about with what speed does it now strike the ground? Like, how fast is it moving right as it strikes the ground? Okay, so this is a two-dimensional problem. That means we have to set up the x dimension and the y dimension completely separately. So I always write down all 6 of the things that could ever happen in kinematics, one for x, one for y, and I start filling them in. So for instance, I'm going to make the decision that the building, like the base of the building, is at a horizontal distance of 0. That would make the initial position of the ball in the x direction would be 0. I'm also going to decide that the ground is 0 for the y direction. Now, that means the initial position in the y direction is 20 meters. And the final, that is, in the end, it is at a height of 0. I am also deciding, I should have written this down actually first, I'm going to decide that up is positive and down is negative, and that in my drawing to the right is positive and the left is negative. Okay, so other things I know. Well, this is a projectile motion problem, so I already know that the acceleration in the x direction is 0 and the y direction is the acceleration of gravity. I know that's 9.8 meters per second squared. I need to decide if that's negative or positive. Well, I've decided that down is negative, so since the acceleration of gravity is always down, then that means this is negative 9.8 meters per second squared. That is a decision you need to make every time for yourself, and it only depends on what you chose for your directions over here. Okay, other things. Let's see. Well, I know the initial velocity was 8 meters per second at an angle of 35 degrees to the horizontal. I need to split that up into its x and y components. So to do that, I actually, I'm going to make myself a little triangle, well, a little bit bigger triangle. So if v naught is 8 meters per second this way, then v, get a different color here, v in the x direction would be this side of the triangle, and v in the y direction would be this side of the triangle. So this would be v naught y, the other one's v naught x. Okay, and I have the angle of 35 degrees right here. Oops, sorry. Okay, so that means that v naught x is going to be v naught, it's adjacent to the angle 35, so v naught cosine 35, and vy is opposite the 35 degrees, so v naught sine 35. Oh, I guess I have a number for v naught, so I should probably actually write that number in. Whoopsies. Although this brings up a good point. If you don't know v naught, that's what you would do, is you just write v naught sine 35, v naught cosine, and work with it from there, see what you get. Okay, but this time I actually have numbers, so I'm going to put those in. All right, check on your signs. Let's see, this thing was moving up and to the right, so I should have positive y and positive x. Please note that if I had chosen up to be positive, for instance, or sorry, if I had chosen up to be negative, and since this is pointing kind of up, I would have put a negative on here, but the way that I've set it up, everything's positive. But that's something also you need to check every time. Okay. Other things I know, Okay, if AX is 0, then VX doesn't change. So this is also 8 cosine 35. Okay. All right. That is, just let me check. Yep. Yep. That is everything I know. Okay, that's everything I know. Now I want to know delta x, so I want to know, let's see, it looks like I want to know this. And I also want to know v. Now to get v, I'm going to need vx and vy, and I will later put them together with the Pythagorean theorem, but basically these are the three things I need to figure out the answers that I want. Now looking at this, I actually have some choices here about where to go. Usually what I like to do, personally, this is a personal preference, if I can get time, like time makes everything easier. So I'm gonna go and try to find the time first. Now, which set of data do I want to look at? Usually you want to look at the data where like the end of the problem is being designated by like which dimension is designating the end of the problem. So the end of this problem is when this thing hits the ground. That is a vertical position. So I'm going to look at my vertical stuff. So I'm looking at this stuff and I want time. So like it's not my final answer, but it's like a intermediate answer. I need time. Well, I've got, let's see, different color here. I've got everything except for final velocity. So there are actually there's only one equation that has time in it but doesn't have like final velocity or velocity at time t, and that is this one. Now in your equation sheet it'll say x equals x naught. I'm just changing all the x's into y's because you can do that as long as you change all of them. Okay, so this is the same equation in your equation sheet, just with I replaced every single x with a y, and you can totally do that. You just have to replace all of the x's with y's. Okay. All right, so I've got this. If I plug in what I know, it will look like this. By the way, 8 sine 35, you're totally welcome to find out what that is and make it a decimal and like keep it there. I tend to leave things as 8 sine 35 just to avoid rounding error, but like you can totally work it out, especially if you do that, save thing in your calculator. You know what I mean? Okay. All right, so I get this. This is a quadratic in time, so I will have to solve it with a quadratic formula. Okay. I'm not going to show you do that. I'm just going to pause the recording and go do that. Okay, I went and did that, and I got, because it's a quadratic, I got two answers. I got negative 1.61, but there's no such thing as negative time for us, so I'm going to ignore that one. And the other one was 2.542. I'm going to not round this right now, oops, because this is an intermediate answer that I need for later. So I'm actually going to store that in my calculator. So I mean, even this is rounding, but it's like 2.542079062. So I'm going to store that in my calculator and keep it, because now that I have it, okay, I can go add it to both of these, and now it becomes pretty easy to get what I want. So like I want x. Well, x is the only thing left that I don't have. So I can straight up just use whatever equation I want to find x, and I'm going to choose to use this one again because it's already solved for x. Like, why not use it? It's already ready to go. So if I use that, I will get, let's see, starts with a 0, 8 cosine 35 times the time that's stored in my calculator, and the acceleration is 0. So this whole term is just gone. And I get, let's see, just pause it for a second. Okay, I get 16.658 blah 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 blah. I need to round that somewhere. I I set everything up with 2 sig figs, so I am going to round to 2 sig figs, but please remember that we don't really care much about the sig figs as long as you don't go crazy with them. So like most of you will probably want to write 16.7. I'm just going to write 17 because that's 2 sig figs. And that's what my answer rounds to if you are rounding to 2 sig figs. So there's one answer. It goes 17, or it lands 17 meters from the base of the building. The other question is, how fast is it going? So how fast is it going is basically asking for the speed, and the speed is the magnitude of the velocity. Now to get the velocity, what I have to do is make another triangle where this triangle is going to be, let's see, I'm running out of room, but I don't want to erase anything. This triangle is going to be like down this way somewhere, some speed that I don't know, but it will be made up of the speed in the x direction, Vx, and the speed in the y direction, which will be down. I can tell from the diagrams it'll be down the y direction. Now I already have the x direction. It's ready to go. Okay, I have that already. I just need to find v in the y direction. So I've got everything except for that. I can use any equation I want. So I'm going to use the easiest one, which looks like this. So that is going to be 8 sine 35 plus negative 9.8 times the time that I have found already, stored in my calculator. Okay, put that in the calculator, and I get that Vy is negative 20, well, it keeps going. Another thing I want to store, like I'm going to want to store this, meters per second. It's good that I got a negative number because this is the magnitude of the velocity in the y direction, and the negative is telling me that it is down, which is good because that makes sense for here, for this point. It makes sense that it would be moving down, and my x is still positive, that's moving to the right. That makes sense. This is good. Okay, so now I've got both sides of the triangle. I've got negative 20.32 meters per second and positive 8 cosine 35. So now it's just time to put them together into with the Pythagorean theorem. So, okay, the speed is going to be the square root of 8 cosine 35 squared. Don't forget to square the whole thing, not just the 8, not just the cosine of 35. Okay, plus negative 20.32, so I'm going to overlap a little, squared. Please make sure that you enclose that negative inside the parentheses so that it will actually go away. That's really good. And I will get the speed, actually I'll just skip to it, I will get the speed is 21.354, blah, 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 blah. Again, I'm going to round to 2 sig figs just because I set mine up with 2 sig figs. You can do more if you want. Please note when you square root something, it's usually plus or minus, but I'm specifically asking for the speed, and the speed is always the positive number, so that would be it. And here's my other answer, and that problem is done. The other thing you might have been asked is the angle with which it hits the ground. That would just be asking for what angle this made. So we'd be asking for this angle here, which you can get by doing an inverse tangent of the y over the x, or yeah, because it's the same as that. Just be careful when you say your angle. Like if I found this angle specifically, I would need to say like the angle is 70 degrees below the horizontal. Like make sure you're saying it right for the one that you're doing at the time. Okay, that is enough for this problem.